Hello, everyone, and welcome to today's free public webinar entitled Measurement Tools for HVAC Technicians and How to Use Them. My name is Ryan Smith. I am Product Manager here at TPC Training, and I am joined by one of our TPC Training instructors, William Smith. And he's here to really talk to you about all the ins and outs of some of the most commonly and most useful HVAC tools that we can use in the trade. So he's going to tell us all about that today. Before we do, I'd like to just introduce a couple things to you all. First and foremost, this session is being recorded, and this recording will actually be up on our website within about 2 business days of this webinar. So be on the lookout for that, as well as the PDF of today's slides. You'll be able to know a little bit more and watch this back with your coworkers and look back at it with your coworkers and colleagues. And then finally, I wanted to let everyone know that today's session is actually live in the moment, which means that you can actually interact with us on the Q&A line. So if you look at the bottom of your screen, you should see a Q&A button. And when you click that Q&A button, you can type a message to us, and we'll be able to answer those at the end of the session. And we look forward to seeing all your really great questions. And now, before we get to Bill, I'm going to go ahead and launch a poll for you all. We really want to know a little bit more about who's here on the session today, and a little bit more about some of your experiences coming into this public webinar session. So what I'm going to do is launch a poll. So in front of the screen here in just a moment, you are going to see a poll. And we got 3 questions for you. And what you can do is actually to answer any of these questions, you just click on the answer and your answer will be registered. Scroll down and answer the other 2 questions and then submit your answers. And your answers should pop up here. And then I'll share all the results with you to see who answered what on our poll. So the first question is, what type of HVAC gauges do you use in the field? We're going to learn from Bill today. That's one of the most important tools that you can have as a technician. What type of gauges are you using presently? Do you use analog HVAC gauges with the needle? Do you use digital gauges that have a digital readout? You're not sure which gauges are being used in your facility, or you actually just don't use HVAC gauges presently. And then number 2, what type of refrigerant systems do you or your employees work on? And you can do the multiple choice here. Use R22, R410A, R134A, R404A, or you're not sure, or none of the above. And then finally, our last question is, what types of HVAC systems do you work on? Are you working on industrial systems like factories and manufacturing, commercial like schools, offices, and buildings, or residential like homes and apartments, or you're not sure? So I'm going to give you just a few more moments. We got the answers rolling in here. And it looks like the answers are evening out here. Perfect. So I'm going to end the poll. And I'm going to share the results with everyone. So as we see here, Bill, and this is going to be great for us to kind of to know who we're talking to as we move forward with this presentation. Most of you here are using the analog gauges with the needle. 45% of you are using the analog gauges. And then the next answer after that is actually 33% of you are not sure which gauges, or you actually don't use gauges presently. Maybe you're getting introductory into the field, or maybe you're the management of the people who use the HVAC gauges. And so this will hopefully be very beneficial to those folks. And 17% of you use the digital gauges. So almost, what is that? That's almost 3 times as many of you use the analog needle-based gauges than the digital gauges. And question number 2, it looks like it's a dead heat. 57% of you use R22, as well as 57% of you on R410A. So some of you are dealing with both R22 and R410A systems. R134A is next at 41% of you, and then R404A at 22%. And then finally, how would you best describe the HVAC systems you work on? And far and away, 72% of you work on commercial systems, schools, offices, and buildings. So that really is the audience we have, commercial HVAC technicians. So I'm going to stop sharing the results with you. And if you still see the window there, you can just exit out and put the presentation front and center for you all. And without further ado, again, the Q&A line is open. Feel free to ask questions as you hear them and come up with them throughout the session. We'll answer them after our presentation here and before the end of the hour. So without further ado, here is Bill Smith. Thank you so much for being here, Bill.
Thank you, Ryan, and welcome everyone to our presentation for TPC training on technicians and how to use the tools in their job. We're going to go over a little bit about different tools that you might see in the field. If you're starting out, this might be brand new to you. If for some of you, it might be a good review for you guys. And the one thing that Ryan talked about starting out was manifold gauges. So what I did was I brought some pictures here showing you 3 different styles of manifold gauges. The first set here would be a version which would have only 3 hoses hooked up to it. We got our middle section here, which is going to be more expensive style gauges with 4 ports hooked up to it. And some of you mentioned you have and used digital gauges before. This particular type of digital gauge allows you to check and find your superheat and subcooling right on your gauges. And we'll get into a little detail about the PT chart and how we use these gauges to go ahead and find our saturation temperature, the temperature at which the refrigerant is changing in the evaporator from a liquid to a vapor, and the pressure and temperature at which in the condenser it's exhausting heat and causing refrigerant to change from a vapor and back into a liquid. One of the methods for connecting your manifold gauges is if we have what we call a semi-hermetic compressor. Semi-hermetic compressors are unique in that there's parts of the compressor that we can change certain parts. And this is what I like to call the manual access valve. So we're going to go ahead and we're going to hook up our gauges to this center port right here that we have their cap off of. And we're going to go ahead and have our gauge on here. And then by exercising this stem in and out, it's going to allow us access to that port. And we're going to go ahead and have access to that port to go ahead and read the pressures to our gauges. The 3 positions you're going to see on that: normal operating position, which would be we're not allowing anything to come out of the system to our gauges. The mid-seated position, which is going to allow pressure to go to our gauges and completely over to our in and out of our compressor. And then we also have the front-seated, or as they call it here, the dangerous position. The only time we're going to have it isolated is if we need to isolate the compressor itself, and then we can pull the refrigerant just out of the compressor without having to remove the entire system charge. If I go along with this stuff, and there'll be questions later on about didn't understand in full about this. This is a small example of what you're going to see if you were to attend one of our virtual reality classes that we offer from now to the end of the year on air conditioning on every Monday and Tuesday, 8 to 4:30 Central Standard Time. What we're going to look at is the back-seated position. Again, when we take this service cap off, we're blocking off the access to our blue and our red gauge. And when we go ahead and put this in the mid-seated position, then we're going to go ahead and allow pressure to go in and out of our compressor. But we're also going to allow the pressure to go to our gauge so we can read the pressure on our gauge and diagnose our system properly to make sure that the system's running the way we want it to. And then our dangerous position, because what we're doing in this one is we're blocking off any refrigerant from getting to our compressor. We're not cooling the compressor properly. We're not discharging all the high pressure the compressor is building up, and it's dangerous to run it in that position. So those are our 3 positions. And in a second here, what I'm going to show you is the service port we're going to put on here. It's called a service valve wrench. The reason I want to highlight that is because that's a square peg. So the last thing we want to do is put a rounded off to try to turn that. So I don't want to put channel locks on there. I don't want to put pair of pliers on there. We have a special tool for that valve. It's got the square peg already on it with different sizes to open and access the port to get in to check our refrigeration system. Now, in the event that you have a system that has Schrader valves, they're similar to what you would see on a valve stem on your car tire. So whenever you add a hose on there and push it in, you can add and remove air out of your tire. We're doing the same thing here. We're getting a pressure read through this valve stem. And this valve stem is what we see right here. In the event that this valve stem leaks, it does tend to leak mostly because of air on our parts. If you remove one of these Schraders, you should not put it back into the system. Once it's got refrigerant exposed to it, the gasket expands, and then you're putting the gasket back into a smaller opening, and it'll rip and tear that gasket. Keeping the caps on here is very crucial because the caps are going to help seal up the system in the event that that Schrader is slightly leaking refrigerant out from time that we're putting the gauges on till the time we come back to service the unit. Usually you're talking about hooking up your gauges once a year when we're doing what we call a preventive maintenance. So for those who live in warmer climates, you might do it more often. In Pennsylvania, where I'm from, we was tasked with going out in April and by June done, trying to make sure we're finding a problem and diagnosing and getting the system ready for summer. Last thing we want to do is have that hot weather come in the middle of July, and then the system decides to stop working. We want to try to get it preventive maintenance and make sure we have all of the system set up the way we want to do it and ready to go. So if you're out in the call and you get a system that Schrader is leaking, here's an example of a Schrader removal tool. We can go ahead and we can remove the Schrader without having to release the entire refrigerant charge. What we're going to do is we're going to push this stem in, and that stem is going to go ahead and allow us to push in the system here. And on this end right here is where we're going to have our Schrader valve. Turning the Schrader valve to the left will loosen it. We'll be able to have the refrigerant pressure push it back, as you see the handle extended here. And then we can lock off this handle here, and we can move this and remove the Schrader and replace it under pressure. Prior to having this tool, we had to remove all the refrigerant out of the system and then weigh the system back in again. And when you're talking 50 to 100 pound systems, it's a lot of refrigerant you got to remove and then try to put back in, and it's not conducive to a good environment. Now this one we're doing is we move the Schrader, we're also able to access the system through here without having the Schrader in. We're going to talk a little bit about evacuation. Evacuation is when you're removing air and moisture from your refrigerant system. So we can evacuate the system easier without the Schrader being in there and being a restriction and restricting the flow of refrigerant through the system. Here's an example of a Schrader tool, and then we also have a couple of valve stems or Schrader cores right here with it. The handle here is turned to the same direction as the valve. So we're going to be able to have what's happening with this one is we're going to allow refrigerant to push through here until we unscrew this stem. And you'll see the stems here. And we pull that stem out and pull it back, and then we can lock it off. And then we also have access to right here into our system without having to remove all the refrigerant to replace that Schrader. Here's a picture of a Schrader tool or service valve wrench. On a service valve wrench itself, it's going to be listed. Now this, it might say like 1/4 and 3/8, 5/16. So when you flip it, there's 4 different sizes for these stems coming out, depending which side you have attached on here. And then you change your setting here, and it ratchets from either left to right to go ahead and open or close your service system and allow your stem to move in and out to close off the system or to open the system for us to allow pressure to read through. Now on your manifold gauges themselves, you're going to have a quick connect, and this quick connect is there so that way you can go ahead and hook your hose up to this part right here where it's threaded here, close off this little ball valve, and then we're going to stop the flow of refrigerant coming out. So when I unscrew it from this threaded part right here, instead of getting a full pressure of the 4-foot, 5-foot, and I personally carry 5-foot hoses. Recommendation is called carry smaller hoses, but I'd rather have my hoses be able to extend out further from the unit so I can go ahead and read them. Problem is, if you don't have those quick connect gauges on there, then you're going to release that 5-foot, 6-foot pressure in your hose into the atmosphere, and you're going to take more pressure out of the system. So the idea is when you're hooking up your gauges, you want to try to not have as much refrigerant coming out of your hoses because the system charge needs to be dialed in where we want it to be exact. Now, another method of using manifold gauges is, for those who haven't seen this before, you would actually be able to hook these blue and red side up, low side be your blue, red side be your high, and screw it right onto your Schrader, and you will get a pressure, a PSIG pressure right on the gauge. And if you look here, it says 258 degrees centigrade. I can change it so it reads Fahrenheit. And then I take these temperature probes and I clip them onto the liquid line and the suction line of my refrigeration system. And then I could be down in my truck and say, oh, I'm eating lunch. What are my system pressures? And what is my superheat and subcooling? And everything's Bluetooth right to your phone for you. Now, the problem is when you have modern technology like that, obviously you got more cost involved with it. So if you're starting out in the field, might not be a good idea to jump right into something like this until you get comfortable with what we call analog gauges. Now, analog gauges look like this right here. So we have a needle that's going to go across and exercise and show us a pressure on our gauge. And these pressures on our gauges are showing us what the system pressure is. Above atmospheric pressure and below atmospheric pressure on the blue gauge, and on the red gauge, just reading pressure above atmospheric. Why is a blue gauge called a compound gauge? Because it can read above and below atmospheric pressure. The red gauge is meant for just above atmospheric pressure. And the yellow hose is when we're going to move the refrigerant in our system, out of our system, called recovery, or to try to remove moisture and air out of our system by dehydrating the system down below atmospheric pressure. Another example of the digital gauges is right here. Nice, because all your superheat and subcooling is going to be calculated right on here for you. And there's different brands that are out there. This one particularly might be Testo. So there's not a right or wrong answer for what brand is the better. All the gauges are going to read you the same things. They're going to give you PSIG. They're going to give, in this one, they're going to give you the saturation temperature. And on this one, instead of you being able to read it on the gauge, you might have to go ahead and use a PT chart, a separate chart, to read your pressure and the saturation temperature of your system. So manifold gauge set, the valves that are underneath the gauges look like this right here. So what we got is we've got a center chamber which is used to move the refrigerant in and out of our system. If you're just on a regular day just going to go ahead and hook up gauges to check superheat and subcooling, there's no reason for you to have to exercise these blue and red handles. Those blue and red handles are there specifically just to allow you to move refrigerant from one place to the other. If you're charging the system and the compressor is not running, you're going to add refrigerant through the yellow hose through the high side of the system. And if the compressor is running, then you're going to exercise the blue valve to go ahead and add refrigerant through the low side of the system. All depends on whether the compressor is running or not as to which side you're going to use. The manifold gauge set, again, gauges read system pressure. The gauge is meant to read directly the hose when the manifold is closed. That's what we saw in this picture here. So it doesn't matter. As long as that is closed, the refrigerant is going to go right through into our gauges without having to exercise that valve to allow the pressure to go through there. It's going to read right through without us having to do anything to change that. Blue gauge, again, compound gauge, above and below atmospheric pressure. Red gauge, just reading above atmospheric pressure. The blue gauge is meant to read the evaporator side of the system. The red gauge is meant to read the condenser side of the system. Red hose is going to be attached generally on your equipment on the outlet of the compressor, called the discharge side. The blue hose attached to the low side of the system, the inlet of your compressor, called the suction or the low side of the equipment. And the yellow hose, again, used for transferring refrigerant. And in the event that you have the 4-port system, so when I showed you earlier, the larger diameter hose is available to aid in the transferring refrigerant and recovery, making it faster. Manifold gauge set reads pressures in pounds per square inch. For those that are joining us from Canada, last presentation, we had a couple people that joined us from Canada. You'll be reading it in kPal, or kilometers squared. I read it in PSIG. The PT chart, what are your best tools you're going to carry with you? If you go to a service store, United Refrigeration, R.E. Michaels, Pierce Phelps, there's a couple that are in my area, you can get one of these PT charts. What this is showing us, if we have a pressure of 16 PSIG and we have R134A refrigerant, that's telling us that the refrigerant is evaporating or changing from a liquid to a vapor at 16 degrees temperature. Pressure affects your saturation. So for those who are joining us, I live in Pennsylvania. Water needs to get to a temperature of 212 degrees Fahrenheit before it begins to boil. Those who are joining us from Denver, Colorado, you're a mile higher than the elevation where I am. So your water might boil at 205 degrees. So what we're showing you is that by manipulating the refrigerant and causing it to a lower pressure or a higher pressure, we can cause it to change state at different temperatures. And it's important to know what refrigerant you have and what pressure you have using your PT chart. So another picture of our PT chart, what you might see is one like this right here. We're starting with temperature of minus 100 degrees Fahrenheit and then going up. And on the next slide, it's going to go up to higher pressure and higher temperature ranges. Higher the pressure, the higher the temperature. The red numbers are always reading a vacuum, inches of mercury, and the black numbers on this chart are showing us a pressure above atmospheric. So one health tip, PPE, why PPE is so important is right, R22 refrigerant. If you are transferring liquid R22 refrigerant and it is standard atmospheric pressure, if you were to spill it on your skin, you could end up, if you look here and read it across, the difference between the vacuum and the pressure at minus 45 degrees Fahrenheit. That's why the EPA will tell you you should wear gloves, face shield to protect yourself so the refrigerant does not get directly on your skin and cause frostbite. It's going to take the heat right out of your skin quickly. Now, our common refrigerants we're going to see for air conditioning, R22, R410A. So what I'm going to do is on this chart, I'm going to show you a higher pressure, higher temperature range. And two that you're going to see for air conditioning, very, very common. An evaporator temperature of 40 degrees Fahrenheit. So if you run across here, you'll see that this is where that R22 intersects this at. So if I come down the pressure at 68.5 and I say, okay, I'm at 68.5 my gauge, and I run my finger across to the temperature, that means that the refrigerant is at 40 degrees temperature, and that's the temperature at which it is reacting and causing it to change state. But R410A happens to be a higher pressure refrigerant, so it's at 118.9 at the same 40 degrees temperature. Now, another temperature you're going to see, this will be our low side. Our high side of our system might be down here for 110 range. So at 110 degrees Fahrenheit, your R22 on your pressure is going to be at 226.4, but we're going to rise up to about 364.1, pardon me, for our R410A. So we're going to see a difference between the higher pressure is going to be a higher temperature, a lower pressure, lower temperature, but every refrigerant has a different pressure temperature relationship. Now, one last thing on the PT chart is interesting is the fact that because R22 has chlorine in it, it's been phased out. So replacement was R407C. But you notice some of the R407C and the R417A, we see liquid pressure and we see vapor pressure. The reason is because they do not stay together when they're in their vapor state. It's called fractionization. So when you're using your gauges with R407C, or example here, 417A, it's called a blended refrigerant. And we need to know, are we on the high side system, liquid pressure? Are we on the low side of the system, vapor pressure? And what we're looking at is this. We are taking our saturation temperature and we're trying to find out, once we get past evaporating, we're changing it from a liquid to a vapor and then rising up in temperature. Once it changes to 100% vapor, how much extra heat are we adding to make sure we're protecting the compressor from getting liquid back on the compressor? And then subcooling we're doing in the condenser. We're going to take our pressure on our red gauge, convert it to a temperature, and then on our liquid line, the difference is going to be our subcooling. So that's why this PT chart is so important. Now, what's nice about the new gauges are that the PT chart is actually built right into the system for us. So here's our low side gauge, and if you see the 0 to 30 in green here, that's any pressure that's in a vacuum. If we see the 0 to 300, that's any pressure above atmospheric. And if we see it says 300 to 500, it says retarded. That means that it can withstand 500 pounds pressure, but it will not give you an accurate reading. And the same thing on the high side, we're going to see it go from 0 to 800. These gauges are designed for the higher pressure R410 because they go from 0 to 300 and 0 to 800. If you have an older set of gauges that terminate at 250 on the low side and terminate at 500 on the high side, they're not meant for R410 pressures. You have a potential of breaking your gauges if you put on that higher pressure. So the PT chart is built right into your system for you. So if I have 100, so 0 going up to 100, these small lines in between here represent an extra 5, 10, 15, 20, and then 25 would be in the middle between the 150 and the 100. So at 120 PSIG, if you were to look on a PT chart for R410A, you would see saturation temperature of 40 degrees Fahrenheit. That's what we're showing you on this gauge. Is where it crosses this line at actually shows you a built-in PT chart range here. And for those who are in Canada and read centigrade, it would be approximately 5 degrees Celsius. I personally use Fahrenheit, so I just don't want to discredit anyone who joined us from Canada today and not talk about the metric system. So the gauges are designed with a PT chart built in them. Now, this particular gauge just has the R410 PT chart built in. Does that mean I can only use these gauges for R410? No, it means that these only have the PT chart built in for R410. If I used it for R22, I would have to carry a separate PT chart that we saw there earlier, so I can go ahead and read the pressures accordingly. Now, evacuation is the process of dehydrating, taking the moisture out of the system. By lowering the atmospheric pressure, as we lower the atmospheric pressure, we lower the saturation temperature at which water begins to boil. So if I had the capabilities of showing you guys, and I do show it in my PT, in my when I do my virtual reality classes, a vacuum pump with a called bell jar. I could show you that if I had the temperature of 75 degrees Fahrenheit, I could get the water to start to boil at that 75 degrees temperature, even though we were all taught 212 sea level, because I'm lowering the atmospheric pressure in the container, just like we are lowering atmospheric pressure when we go from Pennsylvania to Denver, Colorado, or some of our higher elevations around the United States. When you're hooking up your vacuum pump, the vacuum pump is hooked up like this. We're going to go ahead and hook our blue gauge up on our suction line, the outlet, inlet of the compressor, generally the larger diameter pipe, and the red gauge is going to be hooked up on the outlet of the compressor, generally the smaller diameter pipe, and the yellow hose comes down and connects to our vacuum pump. Our Micron gauge is teed in here, showing us that we can have it connected with the vacuum pump. And when we're checking to make sure we have achieved proper evacuation, we close off this valve right here, and we go ahead and check to make sure the system pressure is holding down to 500 microns without the aid of the vacuum pump. Go back 1 second. Why do we use a micron gauge instead of inches of mercury? On this gauge right here, if we see from 0 to 30, there's not an accurate reading telling us what pressure we're down to. It's just going to tell us we're in a vacuum. We're not going to get a good actual vacuum reading, which is why we're going to use a micron gauge. If you're hooking up a system that is a split system, separate outdoor section, separate indoor section, look for your high side being the uninsulated, smaller diameter, the blue side being the insulated, larger diameter hose. And for those who said they do commercial, you're probably familiar with a package unit. And this is what we call package AC unit. So now all the covers are going to stay on for us checking our pressures, but we hook our gauges up on the outside. There's a tap coming on the outside there, and you simply would hook up accordingly to where it's listed for high side and low side of the system. It's a little more forgiving. You don't have to try to remember, is it the larger insulated or the smaller uninsulated line. The vacuum pump itself. Here's an example of a vacuum pump that we would see in the field. The vacuum pump oil is in this side of the vacuum pump right here in a reservoir. The vacuum pump oil actually attracts moisture and helps in aiding of pulling down and getting the moisture out of the system. How often do you change your vacuum pump oil? Well, the recommendation says to change your vacuum pump oil after every evacuation, because if the vacuum pump oil becomes too clogged inside there, it will not allow the moisture to push out of the system for you. How long does it take to get down to 500 microns? Another good question that comes up when I teach the virtual reality classes. However long it takes. What can affect you getting down to 500 microns? Outdoor ambient temperature can affect that. I have to go deeper in a vacuum if it's colder outside. Less of a vacuum if it's not, to get the water to start to boil off. Larger systems. What's the size of your system? If you have more tube, more piping, you're going to take longer to get it down to the 500 microns. But it's just a matter of getting down to that 500 microns and then locking off your vacuum pump with this blue handle we see here called a isolation valve, isolating it, letting it set for 5 to 10 minutes and making sure the pressure remains on that micron gauge down to 500 microns. Another example of hooking up your micron gauge is here. You can hook up the micron gauge right on your compressor itself. Some of them have a T there like that. So one port's going to be for your micron gauge. One port on here is going to be for your larger diameter hose. Or if you don't have a 4-port system, you might have to use your smaller diameter hose, and that would be for this one right here. The idea is to run this until you see this get down to 500 microns with this isolation valve turned off without the aid of the vacuum pump. And what we're doing here is we're testing the vacuum pump. This pulled down 251 because we want to make sure the vacuum pump is working properly. If there's any leaks in this system, if this cap right here called the valve is turned off where you're going to put your oil into your vacuum pump, it's not threaded in tight, you won't get down to a deep vacuum. A vacuum, again, anything less than atmospheric pressure. So you're not going to hold atmospheric pressure because atmosphere is going to want to push back into the system. And it's not going to allow it to stay down at that lower level. These are some pictures of some micron gauges. For those that are old school like me, I call it, in my class I call it vintage people. You might see one of these older needle going across here like this. And then they came up with the electronic, where I call it the Christmas tree style. So if you ever watch a drag race, they'll time you down, and then when the light goes green, that's when you take off and go. Green here meaning you're down to the evacuation you want to be. Less than green, you're okay. But it's not going to give you a solid number. It's going to give you a range saying I'm in this range, but I don't know where exactly I'm at. So the better option would be this one right here, carrying a digital, so you can tell that you're down to 500. Now, the lower the vacuum number, the lower the micron number, the deeper the vacuum. So is it okay to go less than 500? Absolutely. If you can get it to hold less than 500, go for it. I taught the class just last week, and what was going on was I had a class where one of the gentlemen, brand new, starting, 10 years in the field, carried 2 micron gauges. It was that important to him to make sure that he had a cheaper version of this one as a backup in case this one failed, because he wanted to make sure he was achieving that proper vacuum. Because if you don't achieve that proper vacuum, you've got moisture left in your system, and you're going to go ahead and create acid. So if you're replacing compressor, taking refrigerant out, and you don't evacuate the system down all the way, you're only causing a bomb, which eventually is going to cause the acid in your system to eat through seals, and you're not going to have a proper sealed up leak-tight system. So the next thing we're going to talk about is the recovery cylinder. The recovery cylinder is identifiable by its gray body, yellow top. You should carry one of these for every refrigerant you work with. For my refrigeration guys, they know they might have to carry 5 or 6 of these because they're all different types of new refrigerant that are coming out for colder temperature refrigeration. So your box temperature is 38 or freezer minus 10 degrees. For air conditioning, it's generally going to be seen as R22, R410 are your more popular ones that are out there. This cylinder is meant to take the refrigerant out and store it into our cylinder until you need it. Now, it's not meant to go back into somebody else's unit. It's only meant to go back into your unit or a unit that you own. So if there's anyone that's on this call that works for a apartment complex, you might have 50 different condensing units and 50 different air conditioning systems in your apartment complex. It's okay to take the refrigerant out and put it in here and then say, well, apartment 1C is low on refrigerant. I took this out of apartment 1B. It's okay to do that as long as you own the system, own the unit. You're the owner. Once this refrigerant is put in here, the ideal thing we want to do with it is take it and send it back to be reclaimed. Reclaim would be changing it back into a new or virgin state. So we can put it back to what it was originally, but when we put it back in originally, it's not going to be in this color cylinder. So I know Ryan mentioned about sometimes I have a management that comes to class and says, well, I have contractors coming in, and I don't know if they know what they're talking about. I have to, what came to the class to try to get some general knowledge. Here's one thing I'll tell you. If they come to you, they've never been there before, and they say, you're low on refrigerant, but I've got some in the truck, and they bring this cylinder out, and they've never been there before, that means they're selling you refrigerant that came out of someone else's unit, and it has not been purified. We don't know if there's acid in there. We don't know if there's non-condensables in there. So it's send them home, get them out, tell them, you know, hey, I don't trust you. Okay to do that. There's plenty of contractors that are out there, and unfortunately, we're flooded with ones that don't want to do their jobs properly. It's a shame. Why are we using a scale? Because the cylinder is only meant to hold 80%. So if the cylinder empty weighs 15 pounds and the cylinder is designed to hold 30 pounds of refrigerant, once it reaches 45 pounds, that is my total 80% full. And I can't put any more in that. If you overfill that cylinder, you're not allowing room for expansion, and there's a good possibility that if that cylinder gets hot, pressure goes up, temperature goes up, you can have that cylinder pop off a relief valve, and if it's not chained properly, you've got that cylinder bouncing all over your truck. And I don't know about you guys, but I don't want to hear that thing bouncing around in the back of my truck as I'm driving down the road because A, I didn't chain it properly, or B, I didn't go ahead and make sure that I didn't exceed the 80% full, which I didn't want to exceed that percentage. So it's identifiable by its gray body, yellow top. The two valves here, one will allow us to pull liquid in or out of the system, and one vapor in and out of the system. It's going to have a tube that comes down on the high side, red side, which is going to dispense the liquid down the bottom of the cylinder and pull the vapor off the top of the cylinder. Electronic scale, got to have it because weighing your system charge in on your data plate of your system, it's going to say the system holds 10 pounds of refrigerant charge. The only way you know how much you put in there is to weigh it. You're going to have to weigh it in accordingly. This is a picture, another picture of a recovery machine, some different recovery machines we see. This is a new style recovery machine. The older style recovery machines that I started out with could not recover liquid. So it made the process longer. I had to recover only as a vapor, and it takes a while to get all the vapor out. Where liquid, I can do it faster. Where these machines now will tolerate liquid as I'm pulling it off and allow me to go ahead and do a recovery faster. In a second here, Ryan and I are going to talk, and Ryan will answer some questions, but one question I asked Ryan is, if he remembers, he had a system where he had some problems, and Ryan and I were on the phone quite often talking about that. If they did a recovery, Ryan, they're getting paid by the hour at your facility, at your house. You don't want to sit there and watch this guy taking 4 hours to recover your refrigerant out and charge you 4 hours when he can do it in half the time or even an hour's time. That's why we developed ones that we can go ahead and use and pull liquid out for a faster recovery process. Here we see, again, our manifold, or excuse me, recovery cylinder, identifiable by its gray body, yellow top. Stamped on the cylinder itself is going to be the weight, so we know the proper weight for the cylinder, and we have a relief valve here that in the event you do overfill the cylinder, there's a possibility that the pressure is going to get too high and we need to go, and we got a problem. It's going to vent the refrigerant out of the cylinder for us. So a question that I get caught up in class is, what if somebody doesn't label? This is not labeled. I have no idea what refrigerant's in here. That's where you're going to use your pressure temperature chart. I'm going to take a gauge and I'm going to hook it up here on these valves, and I'm going to get a pressure. And I'm going to take a temperature probe, and I'm going to tape it on the side of the cylinder so I can go ahead and get a temperature. And the comparison between at what temperature refrigerant is versus what pressure it is, where it matches up on that chart, tells me that's refrigerant. That's what the refrigerant is in that cylinder. If it does not fall anywhere, pressure temperature relationship on that chart, that means that somebody mixed the refrigerant together. They didn't want to bother to take the time to see if it's R22 in there, and they mixed R22 and R410. And what they did then was they caused your company money to have to go ahead and send it out and have it destroyed. So instead of getting a reward for saying, good job, now we got some R22, we can go ahead and we can reuse the R22 by purifying it. We're not able to do that anymore. Last part of this presentation is leak detection. Very important. If you go out in the system and it's leaking, you've got to identify the leak somehow. One way we're going to identify the leak is using an electronic leak detector. Our electronic leak detector is going to react with the chemical that's in the refrigerant. So for electronic leak detectors, a lot of times they won't detect the newer refrigerants that are blended refrigerants. We're going to have to go ahead and add some R22, add some 134A, a small amount, and then pressurize the rest of the way up with nitrogen. And when we find that leak using electronic leak detector, this will beep like a Geiger counter. It'll start to whistle at you. And when it whistles at you, it's letting you know that that leak is in that general area. It's not going to tell you the leak's right at that spot. Ultrasonic, the same thing, general area. You literally put headphones on and you take a sniffer and go around and listen, and where you hear a whistle, you know that's where it's leaking at. Refrigerant's heavier than air. So if I'm checking the bottom of my package unit, if I'm checking the bottom of my evaporator, indoor section, or condenser, I'm only knowing that there's a leak in that general area. Soap bubbles will pinpoint that leak. That'll tell us specifically it's at that spot. Fluorescent dye has been introduced in the market for a while. Car air conditioning uses fluorescent dye. It hasn't been as popular for residential. Fluorescent dye, you add a dye to the refrigerant, you run the refrigerant system, and then you take a black light and go over, and if it glows in that area, it lets you know that's where the leak is. Last two things for this presentation, and I thank you for your patience and your time, is a charging cylinder. The charging cylinder is the old style. If someone carries one of these around, they've been around for a long time. We didn't have electronic scales back in the day. So we would go by volume. We would add liquid until we reached a certain line on this charging cylinder, and that would tell us that for each of these lines, we marked on here 1 pound, 2 pounds, and so on all the way up through. The idea being that once you have this refrigerant in the cylinder, you know what weight you have, you can put it into your system and charge it according to what weight you're calling for the system. Problem is, these tend to leak after a while. Then why not just use the regular cylinder like we've seen with a recovery cylinder with the scale? It makes it easier. Last one, the halide leak detector. Again, I call you vintage out of respect. If you use one of these, you've been around for a while. This was my original leak detector. The idea being you screw in a propane torch and you turn it on and have a flame right up in here where I have this red dot. And when that flame comes on, you take the hose and you sniff around your line. And when you find a leak, the color of the refrigerant coming and reacting with the flame would cause it to like a bright purple color. And that's when you know that leak is at that spot. Why they go to electronic? I actually know guys that said that they won't allow an open flame in any of their facilities. So they have to use electronic because they can't have an open flame to check for leak detection. So ladies and gentlemen, it's been a pleasure for me to present this to you. It's a small portion of what you will see if you come back for my virtual reality classes. I actually had a gentleman, we did another presentation 2 months ago that came, hey, I came to your presentation because I liked what I saw. If you like what you saw, please consider taking some of our classes. And at this time, I'm going to turn the presentation back over to Ryan. And Ryan, go ahead, sir.
Thank you so much, Bill. I really appreciate your time and showing us a little bit of tricks of the trade on some of these measurement tools. Now, our Q&A line is open, y'all. So this is the Q&A session, and we're getting a couple here and there, but definitely feel free to ask more. So the Q&A button right at the bottom, if any of these topics really sparked your curiosity, or hey, how about this tool, and can you tell me a little bit more about this or that? Feel free to ask our questions. We got 15 minutes here to ask questions before the top of the hour. So let's definitely do so. Q&A line, type in your questions. Now, as you're doing so, I also wanted to remind everyone, I mean, Bill was able to squeeze this all in, right, in this 1 hour, and that's been an incredible amount of information that we can get out to you for the public. And this really, again, gives you guys a taste of what this is all about, but to really learn the more detailed ins and outs of HVAC, it's really worth your while to take a 2-day course with 2 8-hour days of training where you really can spend time asking questions of the instructor. And also you can get EPA certified with the 608 to handle your own refrigerant through taking training courses, as well as do more advanced hands-on air conditioning skills-based training where you can actually put your hands on a real or virtual air conditioner in the classroom. So just keep that in mind as well. And then the next thing I'll let everyone know here as we're getting the questions coming in is this webinar is actually the second in our recent series of HVAC webinars. So about 1 month ago, we did a webinar on the refrigeration cycle. So if anything Bill said seemed to go, whoa, what is he talking about? I say go back to our recorded webinar list, public on our website, and watch back Bill's presentation on the refrigeration cycle and kind of what pressure and temperature and how they relate to each other and the different parts of a refrigeration and HVAC system. Write that down. Getting all the components of the HVAC system, because then you can really be listening back to this webinar and know, okay, now I know what he's talking about by high side, low side, condenser, compressor, compartment, and all the other stuff we talked about. So there's really a lot to learn, right? You can't learn it all in one day, but this hopefully gives you some really great info to start talking about with your coworkers. So got some great questions flowing in here, and feel free to use the Q&A line to do more. The first question is on the topic of that Micron gauge, Bill. If oil gets into your Micron gauge when you're using it, will it not work properly? Any thoughts on that?
Yes, and the idea is to make sure that the micron gauge, if possible, is isolated from the system. So what we see here in this picture is when we have this micron gauge hooked up, is that when we're pulling the atmosphere through, if any oil comes out, it's not pushing through the micron gauge itself. So when we hook up the system, and we saw this other picture back here, that is, sometimes people do it this way. They'll hook up the micron gauge. But the problem is that it's pulling through the micron gauge to get back through to the vacuum pump. So the idea would be if you had the option of hooking up to another spot in your system, for instance, you might see this right here. You're going to see where you would have a high side port right here. That'd be your better option to put your micron gauge on that spot.
Gotcha. Well, thanks so much, Bill. Let's see. Person on the line is asking about advanced charging class, if that is something that TPC is in the business of. And yeah, we definitely get more into the advanced ins and outs of charging, and we actually have hands-on equipment in some of our hands-on air conditioning course that is on our roster. So we can come to your facility, do some of that advanced charging, or you can come to a public location. Also, virtual, right? Virtual instructor training. Someone's asking about virtual. How can you learn virtually with air conditioning? And the answer is just like we're doing now, right? We're learning about air conditioning, but the difference being you're going to be able to see the instructor and some of his equipment. He's going to be showing it to you in person, and also you get your hands on some of these virtual air conditioning simulations as well. So live.tpctraining.com. You can see here tpctraining.com. You can see all the all the info about our upcoming air conditioning classes in your area, and the ones happening weekly or bi-weekly online as well, where you can just log in on video chat and connect with the instructor during those courses. Okay, Bill, so here's another good question. Let's see. Can you change refrigerant types with existing compressors? So let's say we had a compressor running R22. Can you switch out to R410A without having to change out the existing compressor? Any thoughts on that?
Good question, and that comes up a lot of times in my training process. No. One reason is because, as I showed you on the PT chart, at 40 psi or 40 temperature, we get 70 psi G for our 22. We got a higher pressure. So whoever designed the system is designing it for either the lower pressure or for the higher pressure. And the other reason would be because is the oil is not compatible. There's different oils, mineral, alkylbenzene, polyester, and they have different oils that are compatible with different refrigerants. So if you took all the 22 and just charged 410A in, if the coil is not designed for the higher pressures, you got a problem. If you didn't take the oil out, you're mixing oils and you're causing the system to be acidic.
I see. Excellent. Well, we got a message coming in as well. Someone's curious about what TPC and TPC training stands for.
We
That's a
got
really
that
great
one too.
question.
Go ahead, Ryan.
Yeah, we actually come. We've been around for so long that sometimes we forget what TPC stands for. So nowadays, TPC stands for the three prongs of what we deliver to our customers. So that's training, that's performance, and that's compliance. So basically, we help train your folks, we help make sure they're performing to the highest degree, and then we make sure they can find compliance to all safety and government regulations. So that's really where TPC's creed comes from: training, performance, and compliance. And yeah, I did kind of mention, are real classes happening now with everything happening? And the answer is yes. Really, there is something to say about virtual training, right? So our focus as a company is in what we call VILT, or virtual instructor-led training. 100% safety there, where you can actually connect with the instructor online, have the full audio and visual experience, and you'd be surprised at how much interaction you can achieve as well. Hands-on, skills-based interaction about the tools, tricks of the trade, and troubleshooting methods for air conditioning in the classroom, the virtual classroom. Our company still has on the schedule a bunch of different city locations for public enrollment classes as well, but really they will hold as see fit, and our company really takes very special care on ensuring the safety of anyone who shows up to those classes. So it's as you can imagine, a constantly changing environment out there, but our operations team is just massively experts at making sure all the different locations we have are in the best safe possible, that the regulations are cleared, the different rules in the different states, or even counties or cities in some cases. Great question. So, so that compressor one is out of the way. Are you familiar with approach temperature? Did we talk about that, Bill?
Approach temperature?
Approach temperature. I wasn't sure what that meant either. Someone has asked, how do I determine the approach temperature?
See, the temperatures we talk about can be two different things.
Okay.
For the actual air conditioning system itself, one approach temperature you might talk about is the drop in temperature. So Ryan, inside of your house, the temperature that you're getting returned across your evaporator versus what you're getting out, looking for a 20-degree difference in temperature. So your room temperature is 75, your supply air coming out that's supplying after it goes across your evaporator should drop in 20 degrees, should be about 55 degrees temperature. Now, approach temperature could also be talking about, for a water-cooled condenser, they're talking about the temperature at which the refrigerant is giving off its heat to the water. So we do go over that in detail, Ryan, in our virtual reality training classes. We do cover that water-cooled condensers and talking about the approach temperature. I'm not sure if that exactly answers the question, but that's what I'm leaning towards there.
Excellent. Thank you so much. Someone's asking about that EPA certification. And so to get EPA 608, which is the handling of refrigerants in three different types, type 1, 2, and 3, for small scale, commercial scale, and large scale. appliances for air conditioning. So EPA is really a national entity. So if you're asking about Florida in this case, as long as you are meeting the requirements for the national certification, you can get that. And what that requires is basically there's a bunch of different requirements, and you can actually call TPC here at this number you see to get all the information on how to get EPA certified in your area.
Ryan,
847-808-4000. Go ahead, Bill.
can I
Any
add
other thing you'd
one
like to
thing to
add?
that? I apologize, sir.
Yeah.
We do actually offer the EPA test at the end of our presentation. So part of
Right.
your cost for the class, for the virtual reality class or the live training class, is you can have the opportunity to take the EPA test. It's part of the cost. So
Indeed.
test is offered.
Excellent. And so comment here comes in, and again, we only have 5 minutes left. We're going to try to answer the rest of the questions, and feel free to ask any last minute ones. Air measurement tools, any comments on how to measure air measurement and how it might pertain to air conditioning?
Good question, Ryan. And it's a lot of information to go over for a little
For sure.
40-minute, 5-minute presentation. What do you add? What don't you add? And one of the things we could have talked about, and maybe we'll consider adding for another class if this takes off, is what we do offer in our virtual reality is talking about psychrometrics. And psychrometrics is the measurement of moisture in the air. So Ryan, if you're in a 70-degree room and it is low humidity, 30 degrees, you might feel comfortable. But in that same 70-degree room, if we're not getting humidity out and it's 80% or pushing above 50% humidity, you're not going to feel as comfortable. So we're going to talk about in detail on our virtual reality training is the difference between dry bulb and wet bulb temperature. And so, Ryan, in Pennsylvania, we have humidity like crazy. So if it's an 80-degree day, it might feel like 95 degrees outside, depending on what the humidity level is at that particular day. So there's an actual temperature, and then there's what it feels like, a real feel temperature.
Gotcha. Okay. Great. And with a couple more minutes left, let me see if I can ask this one for you, Bill. This is a great one. So we talked about the compressor not really being interchangeable with different types of refrigerants. How about those hoses for, let's say, the red and blue hoses for the HVAC gauges? Do we need to change those out? Let's say we put the gauges on an R22 system, and then a few minutes later we go over to an R410A system, and we're going to use them to measure. How would you comment on the need to change those hoses?
You wouldn't actually change the hoses, but you would have to de minimis release the refrigerant from the hose to the atmosphere to get your gauge to read 0, which would be atmospheric pressure. In the event that I left an extra pressure in there, I would cross-contaminate, and I would take even just a small little bit of R410A or R22 that was in my hoses would be introduced into the system, and I would mix refrigerants together. So if you have one set of hoses and one set of gauges, every time you go from one unit to another, you want to go ahead and de minimis release down to 0. So you're using the same hoses over again, but you're releasing the refrigerant out. It's a de minimis release. It's the only release we're allowed to do the vent to the atmosphere, but it's considered a small amount of refrigerant releasing.
Right. Okay. Excellent. I think we comment on the triple evacuation, Bill. We don't hear techs in the field doing this type of evacuation anymore.
Well,
Thoughts?
triple evacuation, Ryan, again, I hate to keep saying it, but what triple evacuation is, quick, brief description of it would be if you do a compressor change out, there's contaminants that are in your system from the compressor burnout. So if anyone's electrical on this call, we call it letting the smoke out of a motor. So the smoke's going to go into our refrigerant, and we got contaminants in there we don't want. So triple evacuation would be pulling the evacuation down to approximately a level of 1,800 microns, charging the system with nitrogen to flush any extra contaminants we didn't get out, pulling down again to about 900, and then finishing our evacuation. So kind of, I call it triple evacuation, Ryan. We're doing in stages. Instead of going from atmospheric 0 right down to 500, we're going to do it in a couple of stages in between there and flush the system out with nitrogen.
Excellent. Bill, thank you so much for being here. I think I can help address the last question I'm seeing here, and that is training cost, right? So if someone does want to get a 2 days worth of training here, um, check out our website. Live.tpctraining.com is our classroom hub. And you can also just go to tpctraining.com and look up seminars in my area, and you can find anything and then look up the price. Generally speaking, just to give you a general ballpark, if you have just one person going, it's to a class, it's definitely best for you to go to one of our open enrollment sessions in terms of cost effectiveness. And if you are going to an on-site, let's say you want us to come to you and train a little bit on HVAC, we can definitely do that. And really the break-even point becomes maybe 7 or 8 people. If you have more than 7 or 8 people interested in a topic, we can come to you and you'll definitely get your money's worth out of that. You can have up to 20 people for one smaller price. So keep that in mind as well. And for those of you really having folks that what I see here are just in the beginning stages of their training and they want to learn to become certified in their area to service residential equipment, I give a couple recommendations of one, look up those requirements to be certified in your area or your state or your jurisdiction, and definitely do take a TPC training course if it meets those requirements. I think it would really give someone a leg up on their skills. So thank you again for you all for being here, and be on the lookout for our webinars happening every couple weeks for the rest of the year. We got how to read electrical schematics coming up. We have our kind of an introduction to our new learning management system coming up here, as well as a bunch of other great topics on the best practices for on-the-job training over the next year, and a couple other great topics throughout the rest of the year. So keep on the lookout for all those coming through. Thanks again, and have a wonderful day, everyone.